Hi, everyone. Thank you so much for joining us today for episode 2 in the Bringing Your Containers to Azure series. Today's episode is Orchestrating Your Containers with Azure Kubernetes Service. Before we get started and I bring on Sam, I want to go over a few quick things. Please take a moment to read our code of conduct. If I can bring that up, sorry about that. There we go. Sorry about that. Please take a moment to read our code of conduct. We ask that you be kind and respectful to everyone, including our speakers. We want the reactors to be a place everyone feels welcome. Please ask questions using the live YouTube or chat or Learn TV chat. In that chat, I will also be sharing some links to the Reactor Meetup page and monthly newsletters if you're interested in checking out what other sessions we have coming up. If you haven't already, please check in using our event check-in at aka.ms/reactor check-in with event ID 14314, and I will be sharing that in the chat again shortly. Today's session is being recorded and will be added to our Reactor YouTube page in 24 to 48 hours. And finally, near the end, I will share a link to our Reactor survey. If you have a few minutes, we greatly appreciate your feedback. And I will now pass it over to Sam.
Today, we are going to be taking a look at Kubernetes and how to bring your applications to Kubernetes. We're going to be taking a look at Azure Kubernetes Service, but Kubernetes is an open source platform that allows you to bring containers and orchestrate them in the cloud. And so the power of that is you can actually control basically everything about your entire application environment. So this allows you to define websites you might be running, databases you might be running, how the traffic to those services is managed. It sort of allows you to control most of that. It gives you a large plane that you can kind of control your platform. So what we're going to be taking a look at is sort of the introductory steps and taking a look at how you can set up a Kubernetes cluster and deploy new resources to that cluster. Kubernetes uses a lot of YAML. YAML is a configuration language. It's intended to be human readable, and it ends up using a lot of white space to do that. And the intent of that is to kind of define what your intended state is for your environment and allow Kubernetes to resolve that for you. And so what this allows you to do is say, this is the expected state. This is what we would like to see our environment running. And then Kubernetes can go and figure out how to provide that for your services. So this is the application we've been running and working with. It's a basic .NET application that we created 2 sessions ago. And we just have this Docker file. What we're going to be doing is creating this, bringing this to a container registry, and then setting up AKS, AKS, the Azure Container Service. And then from there, we're going to be working on how do we actually get this running inside of that container or Kubernetes service so you can actually access it and run it and control it. Cool things that Kubernetes does, because you've defined that state, it's not like a single container, or if you run Docker and then stop that container, it goes away. Or if that container fails and is no longer around and has stopped, Kubernetes is actually able to resolve those for you a lot of the time. It can restart services and reschedule them on different nodes. So if you have we should talk about nodes first, probably. Nodes are the computers. Effectively, what Kubernetes does is collect a number of computers into this large mass that you can schedule specific resources onto. In this case, we're going to be scheduling our container here onto Kubernetes. And what this is going to allow us to do is say we want 3 instances of this. This way, we'll be able to say, give us 3 instances, maybe spread across multiple nodes in our cluster, so multiple different virtual machines or computers in that cluster of machines, and then allow Kubernetes to figure out how those machines are working and send requests to them as they come in. So let's just get started with some of the shopkeeping stuff. We're kind of starting from scratch here. I felt like that would be a nice way to kind of get everything back up. I'm going to breeze through a few of these setup steps. Again, a lot of this is intended as demo material. So there are some steps that you probably don't want to do if you're intending to run, say, production stuff in this. That is not really what this demo is doing. It's sort of intended to kind of break the ice and allow you to explore these services and get to know them a little bit more and kind of remove that first step that can be a little bit hard to get into. So first thing we're going to do is create a resource group. So let's create this in US West. Yes. There we go. If we can make that a little bigger. And then let's create our container registry. So container registries store your containers. They allow you to access your container and pull them. We walked through how to build this and how to access it in a little bit more depth in the previous episode. So in this case, we're just going to be creating this. Also, AKS, the Azure Containers Service, or Kubernetes Service. I'm going to be mixing those up a bit. The Azure Container or Kubernetes Service allows you to actually make that bridge a little bit nicer. So it can actually do a lot of this stuff for you without you having to go and create a service account yourself. So let's create that container registry in our demo. Name, let's call it Sam's Cool Containers. Sure. And we'll just create that. Keep making this bigger because why not? There we go. And so what this is going to do, create a place for us to store our containers. Otherwise, our containers are just stored locally on our machine, and there's no way for Kubernetes to access them. We need some way for it to pull them. This container registry is going to give us the ability to actually have something public, or in this case, actually private, that we can store our images in that is accessible to this cluster. So the next thing we need to do is log in. We call this the cool containers. And so what this is doing is logging in on my machine so that Docker on my machine is authenticated to this container registry, which means we can now push to that container registry. So what we're going to do now is tag our image with dockerized.net. That's the image on our local machine. And we want to tag that with Sam's Cool Containers. Azure Container Registry.io. We're just going to call this the Dockerized and v1. And so that created a tag. If we do Docker images, we should see it in here. There we go. Sam's Cool Containers. I've been testing this, so there's a few of them. But again, we have our container. It's tagged now, and it has the same image ID that all of the previous ones that we've been working with did. We're not creating new images when we tag it. All we're doing is giving it a new label that we can actually reference. And then what we want to do is push that. So this is going to do Sam's Cool Containers. This is going to actually upload that image into the container registry for us. If we push this image up there, it should now be accessible. You can see it pushing each of the individual layers for us. What this is going to do is mean that we can actually access this. So this means that our container is now stored up in Azure and accessible in a way that Azure Kubernetes Service can actually access it and pull it and do all sorts of fun things. The next thing we want to do, now that we've kind of gotten our image to a place where we can access it, is start creating our cluster. A cluster is just a series of nodes. There are really two distinct sets of them. There are your worker nodes. I think the names have been changing, so it's a little bit confusing. And then the control plane. The control plane is provided to you by Azure, so you do not need to worry about that in most cases. The control plane is going to store things like the state we were talking about. It's going to actually track that and also manage things like scheduling and how all of your containers across all of your nodes are managed. It's what's doing that. Your worker nodes are the things that you are actually creating a cluster for. They're the things that are actually going to run your workloads. And so what we're going to be doing is creating a container registry with just one node. This is not ideal. This is not typically what you would want to do. The advantage of doing it with just one node is that it costs less. So if you're just trying to test this out, you don't need the resiliency that multiple nodes provides you. The reason you would want multiple nodes is, let's say we were talking about running this 3 different times. So having 3 different instances of our container running out in Kubernetes. If one of those nodes fails for any reason and is no longer accessible, because we have 2 other nodes, we would be able to just immediately start sending traffic to those other 2 nodes. And so we wouldn't have as much downtime as we might expect if we needed to completely bring back a new node. Because we're not making multiple nodes, we don't get that advantage. So that's what we're going to be doing here, is just creating this for us to access. So the default, if you do not specify one, is going to be 3 nodes. That gives you a little bit of that redundancy, but you can override that if you would like. So Sam's cool cluster. We're doing really good on the naming side. So resource group. Then I called it a demo. That was great. Anyway, then we want a few special things. The generate SSH keys is going to give you an SSH key to actually access your cluster, and then attach ACR is going to attach you to an Azure container registry. So Sam's cool containers. And so that part there is actually going to do a lot of the service account stuff that we had to do previously when we were working with container instances. This should create that automatically for us. If I run this command right now, we would get a cluster with 3 nodes. We can do that now, but if you would like to change that, you can do node count and set this equal to whatever you would like. So if you want node count 1, that should just create a cluster for you. If we spell this right, there we go. 2 dashes in my SSH keys. So if we run this, we will get a few different things. This is probably a good time if anybody has any questions about Kubernetes to ask them, because what this is going to do is actually spin up those nodes for us and actually provision them for us. So this is in the background actually configuring and assigning those nodes for us. Unfortunately, this part is not very fast, but it's something that you only need to do this one initial setup time. So you're only going to run into this when you're trying to provision new nodes for your cluster, not when you're trying to assign or schedule containers into that cluster. So yeah, I think that's mostly it. If you forget this step, like if you do not attach the Azure Container Registry here, you can go back and update that using, let's just skip over here. You can use AKS update to automatically, let's make this much bigger. Here we go. Make this a little bit bigger so we can do our cluster name, cluster resource group, demo, and then attach ACR with the registry name. So whatever your registry is, this will actually attach it for you if you've already created this cluster and then created your container registry and want to attach it after the fact. So that's how you would actually go about doing that. Yeah, I don't see any questions, so I'm just going to talk a little bit about a few other things that I kind of have here. Unfortunately, this part is just the slowest part of this. There are a number of ways you can run Kubernetes locally. We will get to those at the very end, but a few of those allow you to kind of do a lot of this Kubernetes stuff locally. Hold on. Could you summarize what the Azure Container Registry does? Is it like Docker Hub? Yes. So Docker Hub gives you a whole bunch of typically public containers that you can access. So if you've used like Ubuntu, and I think we're using some of the other stuff. But yeah, if you've used Docker Hub, it's very similar. The Azure Container Registry, though, allows you to create something that is private for you inside of Azure. So if you want a private container registry, you can create that. I think the initial one is relatively affordable and pretty nice. It's build based off of size. So as long as you don't exceed a specific max size, you can just have a whole bunch of private containers. So if you have something that you're trying to do and you don't want it on public GitHub, for example, or you don't want it public on Docker Hub, this allows you to do that without publishing those things. So that's what we're doing here is we're kind of creating this privately, which means that nobody else can access the container image that I pushed, which is a little bit different than if we had done this to, say, Docker Hub to a public image registry. Cool. All right, so that's done. So we now have our cluster. Are there any major differences between the services offerings of AKS and the AWS equivalent? I am not sure. I am less familiar with AWS. I am aware, I believe, that all the different Kubernetes offerings between different cloud providers do provide slightly different sets of features. A lot of it seems to resolve around that control plane that we were talking about. In Azure, that's managed for you. that isn't always the case. So that may be something that you want. If you want more access to your control plane and you want to do more stuff there, that it should be, yeah, that's going to be the thing to look at. But I don't, at least as far as I've been using this, I haven't seen any issue where one would work better than the other. They're just slightly different in how you interface with them. Yeah, that is our container Kubernetes service. Okay, too many acronyms and too many things, too many services, microservices. Anyway, so we want to work with this now. We want to actually connect to this because we created our cluster, but we can't actually get to this. We can't do anything with this. It's not that useful. All it's doing is creating a VM out in Azure for us. So we could go in and look at the portal and see that. But let's actually connect to this. Let's actually get some credentials so we can actually work with this. What you're going to need for this demo is something called kubectl or kubectl. There's a major debate about what to call it. So you can call it whatever you'd like. Doesn't really matter. But kubectl is going to actually manage these things. So if we look at our configuration, this is what is used to actually go out and connect to different things. So if I've done my job correctly, we only have Docker Desktop. Docker Desktop automatically can give you a Kubernetes service, and I have taken advantage of that. So I have a Kubernetes service locally running on my machine, but I don't have the listing for the one we just created in Azure. So we need to go and actually get the credentials to connect to that. That's what we're going to do now. There we go. So let's get credentials. That's the command. Give it our resource group of demo and the name of Sam's cool cluster. And so you'll see this gets merged into my kubeconfig. Kubeconfig is a configuration file that we were just browsing. This is an actual file that's on there. I am not going to show you that file because it has a bunch of keys that I would prefer people not have. So we're just going to look at this redacted version, which is automatically kind of pulls out all of that stuff that you don't need. But what you can see now is that we have actually added a user for our cool cluster with all of the tokens and stuff moved away. And then we also have a context here, which is the context to connect to our cluster. So this is going to give us a user and a cluster. Defined users down here, and the cluster is up here. So these, there we go, are sort of the information for the things that we need to connect to. So that gives us a way to actually go in and connect to these things. So if we want to do that, we can see what we're using: kubectl config get contexts. This is going to list the two contexts that we have. If you've been using, say, kind or minikube or something like that, this is going to look different. But you should see the listing of all of the clusters that you've configured. You should also see a little star next to the one that is currently active. When we got the credentials, it automatically, the Azure CLI automatically assigned this one as our current context. If you want to switch back, the way to do that is kubectl config use context. So we can go Docker Desktop. And now we're on Docker Desktop, and we can go back. Because we actually do want to use Azure for this. So there we go. We're back on our cool cluster. Awesome. And now we can actually start working with this. We should have access to our container registry. We have a working cluster that we can actually work with. The problem is there's nothing there. Get PO or get pod is the default, or I guess the basic unit of a object in Kubernetes. This gets complicated. There's a lot of things that are complicated about Kubernetes, and definitely a lot of things that I just do not know about Kubernetes. It's a very, very big project with lots and lots of contributors from lots of different people. Pods describe a set of containers. And so what this is the basic one that we're going to be creating is just one container that defines our application. So we're going to give it the container, the image, and the port to connect to. and that should be that for the pod. But we can make this much, much more complicated if we want to. You can run sidecar applications, which are going to be processes running alongside or shipped alongside your things. So for example, if you need something for logging, or you need something for data management or things like that, you can actually contain a bunch of these inside of your pods to manage that. Lots of different things use these in different ways. We're going to try to avoid that because that gets complicated. Again, we were talking about YAML. This is where the YAML starts. So we have our cluster. Let's actually create some YAML. So let's just create a folder here. And we're just going to call this resources. You can call it whatever you'd like. It doesn't really matter. This is just a thing. So what we need is a pod.yaml. And so this is going to give us a description of our YAML. You probably want to just copy this from somewhere. We're going to kind of walk through writing this. I think that will kind of help explain a little bit more about what all of this stuff is doing, and then we'll move on from there. Again, deploying raw pods like this probably isn't what you want to do when you're working with this. You'd probably like to use deployments, which we're going to get into in just a bit. But deploying just a pod is sort of the base unit that you might want to work with. So first, we need a version. So this is actually the API version of the schema that we're using inside of this. And then we need to define the kind of thing we're going to be deploying, in this case, a pod. And then we need some metadata that's going to describe our pod. And then we need the spec, which defines the resource that we're actually going to be deploying. So those are sort of the main components. I have a Visual Studio Code extension for Kubernetes that's providing a lot of this. It should just be, oh no, Kubernetes, there we go. So if you install this Kubernetes plugin, you'll get some resources. We're actually going to see some errors as I'm writing this that we'll address later, but this is sort of the basics. It gives you a little bit of that extra help when you're writing these to make sure you're kind of adhering to the schema that is expected with these files. If you don't, you're going to see an error. So we need a name for this application. I'm just going to call it Dockerized. That's going to be the name that you're going to see when we deploy this. And then I'm going to give it a label. This is useful later. This isn't particularly useful now. I'm just going to call it the Cloud App. And then a spec is going to actually describe what we're doing. So we are going to play a set of containers with a list. So if you're unfamiliar with YAML, these dashes represent lists. So we're creating a list with a set of these different pod or different containers inside of our pod. So we want to call this one the Dockerized container. For one, it probably doesn't matter too much. And then we want an image, which is going to be Sam's cool containers, cr.io. And this is just the image that we deployed. And then from there, and then let's do ports. All right. The weird thing, I changed my screen resolution and now all of my notes are very awkwardly sized. Is this? Yeah, okay, so we're getting a warning that we don't have resource limits. The way Kubernetes works is you create a series of nodes that run your jobs, that run your pods and all of the things that you're telling it to run. The problem with that is if we deploy this, there's no limit on how many of those resources this thing is going to consume. So there's no way to know whether this container is just going to use all of it. Maybe there's an infinite loop or something, and it wants to just consume your entire CPU. The problem with that is if you have multiple of these containers from different applications scheduled onto that same node with the same thing, now you run into issues where you no longer have a very well-functioning cluster because you didn't have those limits. So you can limit different things like your CPU and memory. We're going to skip that for now because it keeps this shorter, and we're just deploying one thing. And we'll add that in just a bit. So this should, if I've done everything correctly, and I think I have, should define our pod. And so what we can do is deploy this. So let's go into our resources and kube control apply -f and give it the pod YAML. This is probably the best way to do this. Apply is a fancy function. It does some extra things for you. You can see in this case, it created a pod called Dockerized. You can just do kube control create, I believe, like create pod.yaml, something like that. But then you have to actually manage this. The cool thing with apply is it can actually update things. So if you're applying things constantly one over the other, it can overlay those changes. And when we start working with deployments, that's actually really useful because it means that you can actually dynamically scale your resources and maybe add an extra instance of your container if the current versions are getting overloaded, or scale it down if they're using too many resources. So we created a pod. So what does that mean? Let's go and look. You can see we have one pod running. It's been running for 54 seconds. You can see ready 1 of 1. 1 of 1 means one of the containers is out of the one is running. If we have a bunch of sidecars or extra containers inside of that pod, that number is going to change. There's a number of different statuses that you can see. Running is the good one. That means it worked. Pod or backoffs are less good. If you want to see more about what's actually happening here, you can describe the pod by giving it the name. So describe pod. PO is the shorthand. A lot of these different names can be shortened just to make the commands a little bit nicer. You don't have to do that. It's just a habit for me. We can just type pod, and you'll see a whole bunch of stuff describing what is going on here. So you can see it pulled these images and basically all of these information about what was deployed to our cluster. You can also see events here, which are useful if you're trying to debug something and like if your pod is not working, if it's crashing. This can be a good place as a first start to kind of give you a few clues about what's actually happening. You'll typically see those under the events. Then let's make this a little bit nicer. Also, just to prove this is working, let's actually look at some logs. My favorite for this, kube control launch. This, I wrote this down and I don't know if this works. Let's do that. Dockerized. So Kubernetes kube control log. All right, going off the rails here. I wrote that, yeah, logs. There we go. There we go. Can't find our thing, so let's do that. There. All right. So I had to give it the full name there with pod/dockerized because that was the name of the resource. But this gets us our logs. That took a little bit of a meandering route. Yes, kube control logs. I probably didn't. Oh yeah, I don't need the pod. That's why. That works too. Good call. So this gives us the logs for our application. Unfortunately, nothing fancy is happening here. We haven't really implemented an application yet. We just built the basic .NET thing, and I don't even think there's logging for that. So this is just the basic Kestrel stuff that you get when you start your application. But this is a good way to check your logs. If you want to see what's happening in your application, this can be a good place to kind of see what's happening in your application. The next thing we're going to do is add a service. So these pods can have a whole bunch of different things. In this case, we just have one pod with the same name, but that isn't typically the case. A lot of the times you want to be able to scale things. The advantage of something like Kubernetes is it allows you to build microservices. And the cool thing with that is it means you can individually scale specific components in your application. So if you have an order management system and you have orders coming in and something that needs to process the orders, maybe you have a bulk order and you need a lot of things to manage that bulk order at the beginning. But then after the store closes or something, you no longer need to process those orders as much. So you can scale that back down. But you still have a lot of things to process those orders. Maybe you're working overnight to do a lot of the order processing. Different parts of the application can scale, And services give you a way to kind of figure out how to actually send traffic to individual parts of those services. Because we're running multiple instances of what we're working with, it can be kind of hard to figure out which one are we talking to. And typically, if you've done it right, I feel like you probably don't want to know which of your specific instances you're talking to. You want to talk to services, you want to talk about data and the product that you're working with. You don't typically want to know that I want to speak to application 3 of our Dockerized application. That typically isn't what you're wanting. Services can kind of provide an abstraction for that, and they can give you a way to load balance between all of those pods that are running your specific container. So that's what we're going to be doing now. We could split this off and do our own separate thing, but there's a cool feature of YAML where you can actually just create pages inside of the YAML file. And so we can actually use this to just tack on another resource inside of our YAML file. If we do 3 dashes, that creates sort of a delimiter between them. And so we can just start defining a new resource here. And then when we apply this, what we should see, we haven't changed our pod, so that should stay the same. We shouldn't even need to reschedule it or rerun it. It should just be there. We will create a new service though. So another thing we're going to do is just define the service. Service. Name, Dockerized. This probably isn't the best naming scheme that I've come up with here. These names are different because, again, we had the pod / Dockerized in one, and this is going to be the service / Dockerized in the other. They're different, but they're named the same because it's the same application. I don't know if you want to do that, but that made sense when I was thinking about it, so that's what I did. Load balancer is going to actually define what type of service there is. There's 2 different kinds that you kind of want to know. There's cluster IP, which exposes it internally inside of your cluster. And then there is the load balancer, which actually gives you something that is external. So this is actually going to provide an IP that can be accessed externally. And so we should be able to do ports. And give it a selector. The selector is actually going to find specific labels and work with those. So app, cloud app. And so what this is doing, this selector should match what we have up here in the labels for our pod. So what the service is going to do is when a request comes into that service, it is going to find some pod that is able to field that request. The typical one, I believe this is using IP tables, but I don't really know. There's different ways to do the load balancer, like round robin or different things like that. How your traffic is routed can be configured if you would like to do that. But this should be enough to get us started. So let's create that. Control, apply. So the reason I like apply is we don't actually have to change the command we're running. You can see we now have 2 resources being deployed into our cluster. We now have our Dockerized pod, and we have our Dockerized service. The pod was unchanged because there were no differences in the description of that resource. But the Dockerized service was newly created. So now if we go kubectl get service, SVC is a shorthand for that. We should see 2 of these. Cluster IP is the initial one is sort of your Kubernetes initial thing. But this Dockerized thing is the new one, which means we should, if I've done all of this correctly, be able to actually interact with our service through this external IP. So if we run this, hopefully, if I've done this correctly, we should see our service there. Don't know why it's taking so long. Typically, once you get an external IP, it should just work. But I might have mapped things wrong. Oh no, that's not good. So what we can do is describe the service and see what's going on. See if there's anything there that I have missed. And it doesn't, oh, there it goes. Okay, cool. It just needed a little bit of time. That's kind of normal, unfortunately. But eventually, that external IP now leads to our Kubernetes service. So this gives us a way to kind of call that, and also have some way to call all of them. So if we schedule multiple of these things, we can actually get any of them, which means that if we're running our application, maybe we have two, and one of them crashes or is maybe locked up and can't field requests for 5 minutes or something, the load or the requests can be sent to the other pods to help out. This is sort of the cool part of Kubernetes. To really take advantage of that, we're going to kind of remove pods as our thing. Instead, we're going to work with deployments. Deployments are an abstraction over an abstraction of multiple pods, which is interesting. The basic thing is you have pods. Those get put into replica sets, which define a series of replicas of that specific pod. So in this case, we've defined what our pod should be. We've given it a spec of what that should be. Replica set is going to say, give us 6 of those. And go and create those. A deployment kind of provides an abstraction over that to allow you to work with it. So let's mess with that. So to do this, we're actually going to kind of be modifying our pod. This is going to create a few other issues that we can deal with later, but it's kind of a useful progression step. Also, if there's anything I'm going over and it's a little like any questions about that, feel free to ask them. We can kind of meander through this and kind of answer these. These things can be a little bit weird and confusing. So hopefully we're getting there. Spec is going to have a set of replicas. This is the number of things that we want to create. So let's create 3. That's going to say we want 3 replicas of whatever our container is going to have. And then we need a selector. The selector is going to define what type of resource you're doing. Just like when we defined our service, we said we wanted to map traffic to our cloud app. The selector of this deployment is going to specify which pods should match that deployment. So if we want something else, we can do that. This should match something that is actually in your container's spec. So they match. Otherwise, I don't know what you'd be trying to do. That I don't think that makes a lot of sense. So cloud app, and then we need to actually define a template for what we're trying to create, which is basically going to be an entire pod sort of wrapped into this entire thing. So we're going to add a template with metadata and a spec, just like the other pod that we had. And then let's add some labels and an app. Cloud app. There we go. Cool. So this defines our container. We're still getting that issue with resource limits. Again, we'll get to that in just a sec. And that should, if I've done all of this correctly, be everything we need. You'll note we're using the same pod definition that we were using previously. It's all the same. We've just kind of wrapped it in this extra bit of YAML that's saying, hey, we want more of these. Here's how you can figure out how to get them. So the key parts here are this metadata label. This is a key value pair. So the labels here are just key values. You can provide anything you want. So app or run thing. That's all valid. It's just a set of key value pairs that you can match later up here. So maybe you want an environment variable like prod, for example. You can insert these as you want and use different selectors to kind of work with them, or use them in kube control to query different things. So that should be our deployment. And if I've done everything correctly, our service should still map to Cloud App, which should just now have 3 of itself. So what we should see is we should see it create a deployment, and we should see it not touch our service, or it should fail. There we go. Perfect. Awesome. I did it right. So we get a new deployment created, and we get an unchanged service. The one thing that didn't happen is our pod didn't get deleted. The pod that we had created still exists. because the resource is just gone, there's no reference or way to know that the thing has disappeared. There's no way to kind of do that. So we actually have to kind of go in here, git pod, and clean this up. So we have 4 instances of our Dockerized container running, 3 from the deployment, and then 1 that we started ourselves. So what we can do is stop this. I forgot the command for this. So let's figure out what that is. I think it's delete. Yeah, kube control delete pod. I wasn't sure if it was delete or destroy. So anyway, delete pod Dockerized. And now we no longer have that pod. So let's do something else. Don't know why that didn't return right away. It might be waiting for it to stop. There we go. Now we should just have the 3 deployments that we started previously with that deployment. So the cool thing with this, you'll see there's a bunch of extra noise tacked onto there. That's to kind of keep the names unique, because the names need to be unique. Otherwise, it's going to be weird, because a lot of these things are referencing that as the default name. You can also investigate any of these individually. But again, the point of this is that we have something that can be replicated and can be moved around. So these are intended to be something that you can kind of build and then throw away if you would prefer. So if we open another copy there, and all right, figured out how to make it bigger. Awesome. So if we go here, what we can do is actually watch these. So kube control git pods, and we can do the -- watch command, which is actually going to attach something to watch what is happening with our set of pods in this namespace. In this case, we're using the default namespace, but that's extra stuff. So in this case, we have those 3 pods, but we can actually just get rid of one. Let's take this one and just kube control delete pod and do that. And you'll see a whole bunch of things happen. The first thing is that this enters the terminated stage, which means we're in the process of removing this thing. That should stop traffic from going to it. You'll also see a new deployment a new pod gets created for that deployment. So as soon as we start terminating one of them, a new one starts coming up. And then we will create the container and start running the new one. And so now if we stop this, we have 3 running containers again. We just don't have the one that we destroyed. So this is really useful as a way to kind of scale these up. It also means we can just add more of them. So maybe we want 5 of these things. So we can run this and apply it again. And you'll see we configured this. And what we should see is 2 more coming up. These run really fast. These start really fast. That's sort of the point of using something so small. They run really quickly, so they just start up immediately, but you will actually see those start to spin up and eventually get traffic sent to them. Just like the other one, they will start with the pending status, and then once they get into a running state, they will actually be able to do that. There's a bunch of different things that you can do to kind of configure how this works. Kubernetes supports both readiness and health checks. So for example, you can flag something as unhealthy, which will actually just pull the entire service down for you. So remove that pod and create a new one in its place. Readiness checks can also be used to say, this is still in its startup process, don't send new traffic to it yet. So just when something is just starting, if it hasn't finished completely initializing, maybe that readiness check isn't completely full yet. We're not going to do those here, just because that's a lot of extra work. Yeah, we should still be able to hit this. So let's do that. Yay, demos. I don't know if that's exciting or not, but that we're still hitting our services. Unfortunately, there's no good way to demo this more because I haven't added logging for the service. That's coming in episode 4, I think. So we'll get there, but that's kind of outside of the point of this. Anyway, we can scale this up and move it around and kind of tweak things as we want. And as these configurations change, we'll get new services. So let's talk about resource limits because it's really angry at me. So resource limits allow you to define different ways to limit your resources. So how many resources can this thing consume? In this case, we're going to just add these here. And so there we go. This is something that I didn't want to type because it's just a lot. But anyway, we have our resources. This is describing how much that specific pod or that container in the pod is going to request. So what this is doing is defining a set of requests and then a set of limits, which you can't exceed. So in this case, we can use 500 millicPUs. So that's half of a CPU. And 512 megabytes of memory, describing how much RAM you can consume in your service. You can configure these as much as you want. You probably don't want the limits to exceed the capabilities of your cluster. Then you eventually are in a state where you cannot fulfill all of the requests from all of the pods. But what this allows you to do is kind of limit one. So if one runs away and decides it's going to just infinitely loop and steal all of your memory, this can sort of prevent that. You probably want health checks and things to kind of hold that down as well. But this can prevent that from just stopping everything. Because typically you're going to have a lot of services running these. And if one of them starts doing that, that could actually impact multiple different things, all the different things scheduled onto different things. I said things a lot there, scheduled onto different nodes. So just as a demo, let's talk about getting more information about where things are running. So you can add different output types to your Kubernetes services. So -o wide is typically the one that I've used the most. And this gives you a whole bunch of things. This IP is probably not, I suppose you could use it, but again, we talked about sending traffic specifically to specific pods. You probably don't want to do that because if that goes down, or if all of the requests get funneled through a specific chain, you're going to skip all of those other resources you're using to spin up, in this case, 5 different things. But the useful thing here is we have different nodes. We created a node pool of 1. So there's just one thing here. You can add additional node pools to your cluster, or even add Windows nodes to your cluster. So if you want to run Windows services with IIS and Active Directory, that's the thing you can do too. Have not explored that too much. So can't say too much about that. But yeah, this basically gives you information about what node is running on. So again, we were talking about resources. If you consume too much, you're probably going to affect other things scheduled on that same node. So let's actually set those resource limits by applying this. There we go. Done. Cool. All right, so that applies our resource limits, and now those pods should be constrained and shouldn't go too far into any particular direction. We can tweak things as well. The other thing I wanted to talk about is jobs. There we go. So you can also run jobs, which are intended as like one-time operations. They're intended to be processes rather than services. I don't know if that's the best classification, but that's how I've been thinking about it. Again, feel free to ask questions, but jobs are useful if you want to just run something. In this case, we created a whole bunch of these things, and we're running a web browser to actually query this. We can create a job that actually does this. So let's actually do this in a different file. So we'll just call this job.yaml. Cool. And I'm going to cheat just a little bit and grab all of this. The syntax is very similar to what you would have for a pod, but in this case, we have just a template before we create a spec for our container. And then this is going to describe what we're going to run. So in this case, I want to run something that is going to actually query my services. Kubernetes provides a way to query things by the service name. So in this case, we called our service Dockerized. So we can actually send traffic to Dockerized, and that will hit the service and allow it to go wherever it wants. which is pretty neat. It makes sending requests a lot easier. You don't need to worry about IPs, for example. You can just say what we're going to do now. So I'm just going to run a quick shell command to wget with quiet. So -q, it makes it quiet, and then O describes the output, and we're just going to output that to standard O. Otherwise, this would download a file, and it's not interesting. But this is going to actually send a request out to Dockerized, and that's our web request. So instead of sending it out to one of those IP addresses we had previously, one of these things or one of the external one, instead we can actually just send it to something that's named. So we have a named service, and we're just saying, I want this resource of this thing, which works really well when you're working with a lot of REST commands. It just kind of fits into that style. And so that should be everything we need. I'm also going to set the restart policy to on failure, because these are intended to stop. We don't want to just keep rerunning this. And that should hopefully get us a job. And so we can just apply it. Restart policy, running into YAML things. Too many spaces. There we go. Cool. So we created our job that runs the batch, and then we can get logs job.batch. Oh, what am I doing? I'm using way too many random syntax things. There we go. Cool. So this sent our query out. In this case, the response is exactly what we've been getting in all of our other things. Hello world. So we just ran that request, and now we can actually go and see what our jobs are doing. So in this case, we've completed once, we've run our query, and that's that. One interesting thing with jobs is if you start changing things, it gets scary. So if we just want to download the contents of the Dockerized thing, we can do that. We can just apply it, and it will be great. Or you'll get this. This is intimidating. I don't know what most of this means, but it's not that scary. Instead, we can just remove the job or rename it if that's what you'd prefer instead. So if we control delete job, and we want to delete the, what do we call it, query? And now we can apply this and rerun it. And that gives us a way to download that. And so if we actually look, we actually saved our thing now instead of running the thing. So there we go. What else? I think the only other thing that I really wanted to call out is that there are a number of tools that you can use to kind of run Kubernetes locally on your own machine without having to go and set up an Azure thing. So you can kind of step through this on your own machine and then step up to Azure when you actually need something a little more public that isn't just running locally as like a dev environment. So I had already mentioned Docker Desktop, which you can just configure through Docker Desktop. I'm on Windows. This also works on Macs. I don't know about Linux, but you can configure Kubernetes. This way you'll get a Kubernetes instance. You can see what version here. And you just click Enable Kubernetes, and Docker will automatically start with a Kubernetes instance when you start Docker. The other option is kind. So we can just do kind create cluster. And this is just going to spin up a brand new Kubernetes cluster for us, running a much older version of Kubernetes than what Docker is running. And just create a cluster for you inside of Docker. So kind stands for Kubernetes in Docker. And so this gives you a way to kind of create those clusters locally and actually work with them as sort of like throwaway dev environments. It's also really useful, I found, for testing. If you need to test a Kubernetes deployment or something like that, you can deploy it to kind, spin up kind in your test, deploy it, and then just spin everything back down. And it gives you sort of a reproducible thing just based on Docker. So hopefully this goes pretty quickly. There we go. And so if we control config view, we should now have a kind cluster. So kind creates the default cluster called kind. So you have a kind cluster. And so now I believe config get contexts. When are we? Oh no. That's not going to work. Kube control config get contexts. There we go. All right, we got there in the end. Awesome. All right, so kind creates this for us and automatically assigns it just like previously. And so now we can just apply everything we were previously doing to this new cluster and do those same tests here. This might seem a little bit backwards, but I think the Azure thing is sort of the more intimidating and also the cooler and more powerful thing, because that's actually something that anybody can go and access and you can kind of use to run a lot more things. This is more of a dev environment thing. You definitely don't want to use this as anything beyond that, as far as I'm aware of. Could be wrong, but we'll see. So let's deploy that. Kube control apply -f pod YAML. There we go. And so now we've just deployed that into our kind cluster, and we now have those running in both places. If there's any questions, feel free to ask them. Otherwise, that is it for everything that I had to show.
All right. Thank you, Sam. That was awesome. We still have a few minutes left. So like Sam just said, if you do have any questions, please feel free to post those in the chat. While we're waiting to see if a few more questions come through, I do just want to mention that, oh, looks like we have a couple comments. Hold on, maybe. Oh, it looks like you have a few more questions.
Yeah. So can kind run Windows containers? I don't think so. I think the answer is no. Typically, when you're running Windows containers, you need a second node pool to run that. And I don't think kind supports that. I could be wrong, but I just don't think that it works, and I'm not sure. I would recommend like Azure is a good source if you want to start working with Windows containers. They get complicated. The next one, 3 dashes. What is acceptable for using 3 dashes to combine services? I personally combine things that make sense. Typically, the point of YAML is to describe what you're deploying. So as long as that is descriptive, it's just like your code. If your YAML is understandable and makes sense, so if you have an application and all of that is in one YAML file, you can do that. There are also a number of tools to actually work with YAML to configure things in a lot more useful manners. These are very basic demos, and we still wrote a number of lines of YAML. Combined, it's like 50 lines of YAML just to get a basic deployment. They can get much bigger, especially if you're being very particular about how things are supposed to do, and you start working with different policies. This YAML can really explode on you. So there's a lot of tools that can make that a little bit easier for you. So I would say if it makes sense, go for it. And if it doesn't, all you have to do is just pull it out and put it in a different file. So it's not that big of a hurdle or technical debt if you start combining a bunch of things. It just might get a little bit confusing if you're combining things that don't really fit together. Yeah, I think that's something you can just kind of hopefully just choose. And if it doesn't feel right, then do something else. Cool. We have 1 minute left. So I would call out KubeCon is happening right now. So if you're interested in Kubernetes and want to learn more, that is a great resource, and I highly recommend doing that. Otherwise, continue playing with Kubernetes. It's a lot of fun, and it's cool. So yeah.
All right. Thank you so much, Sam. Thanks for everyone for coming. I've shared some links in the chat to our Reactor newsletter. If you're interested in seeing what other sessions we have coming up, as well as to the series page, where you can find all the recordings of Sam's past sessions, as well as the next 2 episodes. And then finally, a link to the survey. Again, the event ID for today is 14314, and hopefully we will see you all here next week. Thanks so much, Sam. Talk to you soon.
Thanks.
Bye, everyone.